Hello everyone. In this video, I would like to go over solving for these two equations, two unknowns, using algebra. What we have done in previous video is we are solving for these two equations, two unknowns, using graphing. And what we found is after we sketch, we found that the point 3, 2, so this point right here, 3 and 2, x equal to 3, y equal to 2, is the point of intersections of the two graphs. Because it is the point of intersection, this point stays true for the first equation and is also stay true for the second equation. Having said that, we have done a very accurate job, right? So it's very tedious using the graphing method, and if we don't do it accurately, we may not be able to find the exact point as expected. Okay, so let's use the different methods to solve for x and y to see if we have the same solution. Graphing is not a reliable method unless we have to be very accurate while sketching the graphs. Okay. The method we are using to use for this particular lesson is either by substitution or eliminations. So these terminology in general is called using algebra. Okay, so these two methods are expressed as solve algebraically or solve using algebra. So when they ask you to solve for a system of two equations, two unknowns using algebra, then you have a choice of using either the method of substitution or elimination. So eventually, you will figure out what method will be best to use. Or they even ask you to do so. They ask you, please use substitution method, please use elimination method, or they can just say using algebra. Using algebra means you can have a choice. Whatever method easier for you, please go ahead and just pick the method that easier for you. However, there are plenty other methods out there, and I can tell you one is called determinant method, method of determinant or Cramer's rule. So that is just a more easier method so that we can tackle the solution where we have to deal with fraction or irrational numbers or irrational solutions. That means we don't end up with a whole number like this, but we may end up with a fraction. Okay, so for these two equations, what I'm going to do is I will use the same two and solve for x and y, but I will apply algebra to solve for x and y. And in the end, we should end up with the same solution as x equal to 3, y equal to 2. And we are going to check to see if this point stays true for both graphs. Because this point is the point of intersection, so it stays on this graph as well. And it also stays on this graph as well. All right, so that means it stays true for both solutions. I mean, it stays true for both equations. A solution satisfies the condition of these two equations. All right, so let's get started. Okay, so I rewrite my equation here. What I'm going to do is I'm going to go over this concept with everyone. I'm going to use some label, okay? I will apply some label, and when I label my equation with number, I will put it in the circle. So I will call this equation number 1, and I call this equation number 2, okay? The very first one is my equation number 1, and the second one is my equation number 2, and don't forget that I put them in a circle. So if 1 inside the circle, it means equation 1. 2 in the circle mean equation 2. Okay, so equation 1 is 2x minus y equal to 4. Okay, so again, equation 2 will be x minus 2y equal to minus 1. So what I'm going to do next is I am going to solve for x in equation number 2, or from equation number 2 I am going to solve for x. Okay, so what do I mean by solve for x? Solve for x mean you are going to shovel everything not having to do with x over to the other side. So equation 2 is like this: x minus 2y equal to minus 1. Solving for x, that means I will bring everything, like all the terms that has nothing to do with x, over to the other side of the equation. Okay, that means the term without x over to the side of the equation. So this will become minus 1 plus 2y. Then I will label this equation as equation number 3. So now I will take equation number 3, okay, and I will substitute into equation number 1. Okay, so that means when you substitute, you are going to use the substitution method. Okay, so that is your substitution method. You pick one equation, you solve for one unknown, and you take that full equation, you substitute into the other one. So I take 3, substitute into 1. So I have to realize what equation 1 is. So my equation number 1 is 2x minus y equal to 4. So let's write that down. Okay, now, so here is my value of x. This is the value of x, but I will substitute 3 into 1. That means I will substitute where x equal to. So instead of writing x, I will write this entire equation in here. Okay, so the position of x will become minus 1 plus 2y. Okay, rewrite everything else exact same again. So do you notice that this equation becomes an equation with just only one unknown, right? One unknown y, so you can solve for y. Because if you notice that when I highlight this for you, you see one equation but two unknown, one equation but two unknowns. Therefore, you need to have a system of two equations, two unknown, in order to solve for these two unknowns. If you have one equation and two unknowns, there's no way you can solve for x and y. And that you have to have two equations in order to solve for these two unknowns. And what you did was you use substitution method to come to have one equation, one unknown. Now you can go ahead and solve for y. So solve for y in here, we have learned this before. We have a coefficient in front of a bracket, so we need to apply distributive rule in order to break the brackets. Okay, eliminate the brackets. So multiply 2 inside the bracket, I will have minus 2, okay, plus 4y minus y equal to 4. So solving for y, I will combine these two I will have 3y, and I bring this over to this side, I should have plus 2. So I have 3y equal to 6. Therefore, I divide both sides by 3, and I end up with y equal to 2. Okay, so let's circle that, y equal to 2. So your next step is you're going to take y equal to 2 and you substitute into equation number 3. Okay, so your equation number 3 is this one. This is your equation number 3. So x equal to minus 1 plus 2y. X equal to minus 1 plus 2y, right? Yeah, so now you are going to, where the y is, you substitute 2 into here. 2 times 2. So in this case, I will have minus 1 plus 4, minus 1 plus 4. I have x equal to 3, right? There it is. So now I have the solution for this two equation to unknown is an order pair of 3 and 2. Okay, so that is the exact point that we found on the graph. Using graphing method. Okay, so remember that we mentioned that if this point is the point of intersection, that means it stays true for both equations. So what do I mean by that? That means you are going to use it point 3, 2, and then you are going to substitute into both equations to make sure that the solution is true. Okay, so we are going to check. So from equation 1, what do you have? Equation 1 is 2x minus y equal to 4. So that's what we identified earlier. Our equation 1 is 2x minus y equal to 4. Okay, so what I'm going to do is I will substitute 3 and 2 into this equation. So what I have is I have to check left side equal to right side, right? So left side equal to 2x minus y. So I will have 2, x is 3, and y is 2. So let's see what I have. 2 times 3 is 6, minus 2 equal to 4. So what do I have here? Right side equal to 4. So they are equal to each other. Left hand side equal to the right hand side. So this is true. Okay, this solution is true for the first equation. Now you are going to use the same point and you substitute into the second equation to see if it's also left hand side equal to right hand side. So equation number 2 is x minus 2y equal to minus 1, right? As we label that earlier here, x minus 2y equal to minus 1. Okay, and then I will have left hand side equal to x minus 2y. So x is equal to 3. So I write now 3. 2 times 2, because 2 is equal to 2, because y is equal to 2. So 3 minus 4, therefore the left hand side is equal to minus 1. So this is what I have. And what is my right hand side here. So right hand side equal to -1. Okay, so from here I can conclude that left side equal to right side. So 3 and 2 are the two coordinates that you found on the graph, is also the point of intersections of the two graphs, and is also the solutions of these two equations to unknown. Alright, okay. So using the graphing method, in previous video we have to look for x-intercept, y-intercept, and right here is we have this is the x-intercept, this is the y-intercept, this is the x-intercept, and then this is the y-intercept, and we connect them all like this to have this two lines, two straight line, like two linear equation. It means the two straight line on this Cartesian plane. The point of intersection that we have is 3 and 2. It means that it is a solution for these two equations and two unknown. Okay, and the point of intersection, it means that this point stay on both graphs. So if this point stay on both graphs, it is a solution for this two equation, two unknown. And if we are using algebra, you can pick substitution or elimination method. You end up with the same solution as well. So how do we know if we are correct? We know we are correct by substitute the solution into both equations. Okay, so you have to check into both equations. You don't just put into one and then conclude. You need to check with both equations to see if they are correct. Left hand side equal to the right hand side, left hand side equal to right hand side, then you can conclude it is the solution for this two equations and two unknown, or the system of two equations, two unknown. Alright, so I will stop here, but in the next video, I will expand further into solving for system of two equations, two unknown, using algebra or solve algebraically. And don't forget, when I say solve using algebra or solve algebraically, means you can use both substitution and elimination method. So what we have learned in this video is the substitution method, but in the next video we are going to learn the elimination method. Alright? Okay, thank you.